in number 3, what you'll see is that they give us certain information. And you are going to do something a certain way and always do it this way. The first thing that I'm going to tell you is when you do your drawing, you will always, no matter what you saw on the previous page, you will always put your angle on the left. So 85 degrees goes on the left. And then you will always label it with whatever they told you that angle was. So in this case, it was angle A. And then you see that they give you a little a, which is always across from the capital A angle. So I know that the 15 must go on the right-hand side. So this 15, that's the little a, has to go across from the capital A, so that's why it's over there. And whatever other side they give you always goes on the left then. So that's 25, and that's always going to go on the left. So let's reiterate what's going on. Angle on the left, always put the side across from it down, and then whatever's left over goes on the left-hand side. So now I have my triangle. What we're always going to do is we're always going to be calculating the height, because everything is based off of this height to determine if there's 0, 1, or 2 different triangles. And the way that you always find the height is always the left side from the previous slide times the sine of the left angle. So in our case, our height is going to be 25 times the sine of 85. And then what you look at is you look at, oh, okay, what is this amount? When I multiply this out, I get 24.9. Once I get this number, I'm going to go back and look at the 3 rules. There are 3 rules. So here are the 3 rules. Rule number 1. Rule number 1 says that as I look at these triangles, if I see that the side on the right is less than the height, then there are no triangles. That's what it's saying. The A is the side on the right, and the highlight is the height. So if the side on the right is less than the height, no triangles. Second rule, if the side on the right is equal to the height, or the side on the right is bigger than the side on the left, there's exactly 1 triangle. And then rule number 3, if the height is less than the right, is less than the left, then there are 2 triangles. Now you can always go back and check this set of rules. These are the important things to look at here. So as you're trying to do these problems, you're always going to be coming back to these 3 rules to see how many triangles there are. Okay, let's go forward again. What I notice in problem number 3 is that this 24.9 is less than, or sorry, the right side is less than this. So back from the rules, what I see is that my right side is less than my height, which I just found. What does this mean? This means that there are no triangles. Why? Because the right side is less than the height. Okay? That means the right side is actually dangling because it can never reach the base. Let's try another one. Number 4, setting up my drawing again. In my drawing, whenever I draw my triangle, angle goes on the left, always first. So 42 degrees is on the left. That was called angle A. Side A is across from it. That's the number 12. Whatever's left over, which is called the B, goes on the left. I don't even care about labeling it. Remember, we're always doing stuff in reference to our height, so I need to find this H. I know that my H is always equal to the left-hand side, which is 22, times the sine of my left angle, which is 42. If I multiply that out, I find out that my height is 14.72. You can try that on your calculators later. Notice how this height is more than the right-hand side. Since my height is bigger than the right, I know that there are no triangles. Since the height is bigger than the right, there are no triangles. So that is rule number 1. Height bigger than the right. Let's try number 5. In number 5, I'm going to do my drawing again. So when I do this drawing, the angle always goes on the left. If the angle's on the left, that means I have 60 degrees on the left. That was called angle B. I don't really care about its name. That means I put little b across from it, which is 45. And whatever's left over goes on the left, so that's a 50. We're always referencing what the height's going to be. So this is my h. And I know that my h is always the left side, 50, times the sine of the left angle, which is 60 degrees. When I multiply this out, I find out that I get 43.3. And since I know that my h is less than the right, which is also less than the left side, I know that there are going to be 2 triangles from my rules. So if you go back, this is rule number 3, I believe. In rule number 3 it says, if your height is less than the right, which is less than the left, rule number 3, there are 2 distinct triangles. Okay, in number 6, we're going to switch gears a little bit. They have all these fancy diagrams, but really what I want you to know is that when you have a triangle that's set up, and this triangle looks like the following, whenever they give you 2 sides in a triangle, like let's say I get the numbers, I don't know, A, and I don't even know what they are, and B, and this is capital C, then if I want to find the area of this triangle, it works like the following. The area of this triangle is 1/2 times, so I should probably wrote area, not capital A, because that'll probably be confusing for some people. I know that the area of this triangle is equal to 1/2 little a times little b times the sine of capital C angle. Let me show you how this works in a particular problem. In number 6, it says, find the area of a triangular lot having sides of 8 and 13 feet and the included angle of 130. So I draw a triangle. Here's my triangle. And I have sides of 8 and 13. They don't tell me where to put them, so I'm just going to put them anywhere. Whoopsie. So I have sides of 8 and 13. They didn't tell me where to put them. So here are my sides that they were talking about, 8 and 13. And then they say I also have an included angle of 130 degrees. Now included means in between the 2 sides, so that would have to be this angle. And that's because they said it was included. So now if I want to find the area of this particular triangle, here's how I find it. I say that the area of this triangle equals 1/2 times 8 times 13 times the sine of 130 degrees. When I multiply that all out, I get 39.83 feet squared. So 1/2 times the 2 sides times the angle that's in between them. Let's try one more. So in this last one, they talk about an area of a triangle having the following information. And so as I draw this triangle, I notice something kind of weird. So I draw my triangle, and in my triangle, I see that they tell me that I have 2 angles. I have the angles of 105, and I have the angle of 50. and they told me that this was angle A over here, and this is angle B up here, which means, of course, this has to be angle C. Using the fact that there's 180 degrees inside of a triangle, I know that my last angle has to be 25. But they also gave me one other piece of information. They also told me that the side in between the two original angles was 2.5. So I know this is 2.5 over here. Now the problem is, in order to use the formula we just talked about, you have to have two sides. So I have to pick a side to find. So let's say, just for the sake of argument, that I'm going to find the side that's across from angle A. Let's say I'm going to find side little a over here. I probably should label that as little a, but whatever. If I wanted to find that, I could use the law of sines to do that. So if I'm going to find the answer to that, the way I would do that is I would say that the sine of 25 degrees, which was angle C, divided by 2.5, which was side little c, should be the same ratio as the sine of 50 degrees divided by little a, which we called x. And then I go back to what we learned about in the first slide, which is I have to multiply the two things that are diagonal and divide by the third. So I am going 2.5 times the sine of 50 and then divide by the sine of 25. When you do that, like the first few problems that we did, you find out that your x has to be 4.53. So now I know two sides and an included angle, and if I want to find the answer to this, what I would do is I would talk about the area in the following manner. I have one more step to do. I would say that my area is equal to 1/2 times the two sides, which were 2.5 and 4.53, times the sine of the angle that was in between those two, which was 105. When I multiply that all out, I find out that my area is going to be equal to 5.47 meters squared. So give that a shot on your calculator, try it out. It's always 1/2 times the two sides and then times the sine of the angle that's in between.